All right, good afternoon, Brody. Today we're practicing using our calculator to find probabilities for the normal distribution instead of using tables or instead of using the 68, 95, 99.7 rule. And the first thing we're always going to have to do is calculate the z-score. We've got to do this by hand. There's no inbuilt functionality in the calculator. In this textbook that we're using today, you're always being told that x is binomially distributed, and then it'll say in brackets n comma p. So the n that they give you is this n and this n. That's the first number in the brackets always. The second number in the brackets always is p. And then we're going to use our calculator to find these probabilities. And I won't show you now. We'll go and do an example and you'll see. Okay, so in this question, we've been told that n equals 120 and p is 0.47. So we've got 120 trials, like 120 people maybe, and 0.47% chance of success. So maybe 47% of them being blonde, I don't know. So we need to find the z-score, which means we need to know our mean, which is n times p, which is 120 times 0.47, which is 120 times 0.47 gives me 56.4. We need to know our standard deviation, which is the square root of n times p times 1 minus p. So number of trials times probability of success times probability of failure, and the square root of that. So we've got the square root of 120 times 0.47 times, now you could figure out this next one in your head, it's 0.53, but if you just do 1 minus 0.47, it removes that extra source of error. And then we get 120, 0.47, 1 minus 0.47, 5.4674. Just 4 decimal places will do. We want to be fairly accurate. Let me move this one out of the way. That's our next question. Okay, so we need to know the z-score. So we found the mean. My iPad's not liking me. So we found the mean. At one point, we'll have found the mean. Oh, come on. I don't want to start again. This is my third time. We found the mean. That felt like a success. We also found the standard deviation. We've been told a particular score we want the probability for. So we need to do z equals 50 minus 56.4 over 5.4674. So that's the particular score we're after. This is the mean of the data. And this is the standard deviation we found. This means, I've got to move this right off. We're trying to find the probability of a z-score less than, oh, I still haven't chucked that in my calculator. Getting well ahead of myself. So we've got 50, take 56.4 over 5.4674 gives us negative 1.17, 057, etc. So we're trying to find the probability of getting a z-score less than negative 1.17. In our calculator, that's my most recent answer. So we need to go into stat mode. So no, we don't press shift. I always do that. Mode, 3 for stat, 1 for single variable, and then we just get out of it. We don't have data to put in. We don't need to. Then shift and 1 for stat. We want to use a normal distribution. We want the probability that it's less than our previous answer, which was negative 1.17. You could just use the answer button here. You would probably be more accurate if you did. The probability that it's less than 1.17 is 0.121. 0.121. Now these probabilities that we get are always the probabilities to the left of whatever we were trying to find. So if we're after one that's more than, we'll just do 1 minus this to find the more than. Oh, what? That's our next question. Who could have guessed? Let me get this one out of the way because this one's inevitably going to take a long time. Okay, so here we've got n is 200. The probability is 0.52. So we need mean, mu, is going to be NP, which is going to be 200 times 0.52, which should come out as 104. Yep. Our standard deviation is the square root of NP, 1 take P. So we've got the square root of 200 times 0.52 times 1 take 0.52, which gives us 1 take 0.52, 7.0654. The Z score for this, don't forget, it's x minus the mean divided by the standard deviation. So our mean was 104. That's going to go there. Our standard deviation was 7.0654. That's going to go there. The particular score we're interested in is 110. So that's going to go there. So we've got 110 minus 104 over the standard deviation was 7.0654. This gave us 110 minus 104 divided by 7.0654 gave us 0.8492. So the probability of Z being less than 0.8492 is, on the calculator, so that's the most recent one I've done, shift 1, 5, 1, and I'm just going to put in my most recent answer, 0.80212. 0.80212. Now the problem is we wanted greater than or equal to this. So if we sketch this out a little bit, this is 0.8492. This probability here is our 0.80212. So the probability of being bigger than this is 1 minus that answer. 80212 gives us 0.19788. That's not too difficult. Now though, we're going to have two Z scores to find and interpret. So N is 30, P is 0.51, our mean is going to be 30 times 0.51, which is 15.3. Standard deviation is going to be the square root of 30 times 0.51 times, in brackets, 1 take 0.51, sound like a robot, 2.7381. Our Z score then is going to be, our first one is going to be 14, take 15.3 over 2.7381. So we're going to start off with minus 15.3 divided by 2.7381, negative 0.4748. Our next one is positive 16. So we're going to have 16 take 15.3 over 2.7381, which gives us, hang on, I'm quite slow, 381. 0.2557. Okay, so we're going to have to check each of these in tow. So for 14, the probability of getting a z-score of less than negative 0.4748. Again, on the calculator, shift 1, 5, and then 1, and then I had negative 0.4748. Gave me 0.31747. The probability of getting a z-score less than 0.2557 is 0.2557, 0.60091. Now, we've got to figure out what to do with these numbers. If we draw, and I want to draw this fairly big, actually I should do this there. Okay, here's the mean, yeah? Now, here's my first z-score. This was where the 14 goes. Actually, let's use the z-score so it'll be less confusing. Negative 0.47. And this is where the other one goes. Positive 0.26. Now, this is this probability. This is this probability all the way over from the left. But I am interested in the probability in the middle, which you can probably figure out is just the bigger one minus the littler one, because the little one's counted twice. So the probability of being in between, and I'm just going to write it with the x-scores because I don't, all those decimals just takes extra time. It's going to be 0.60091 minus 0.31747, which gives me 0.28344. So that's the probability of being between 14 and 16.